Hello, in this Physics Minute video, we are going to explore the force and acceleration exerted on a crossbow bolt. If you're not aware of what that is, the crossbow bolt is the arrow shot out of a crossbow. To do this calculation, we are going to use the properties of projectile motion. A projectile is any object that is being acted on only by the force of gravity.
Now that I've got my crossbow cocked, I'm using a couple of C-clamps to attach to the hockey net. I'm using a laser level to ensure that it is perfectly level. The laser level also is going to be used to determine the origin on the target. That way I can calculate the displacement.
So now we have my crossbow set up and level and we have the target marked. Now it's time to actually do the experiment. We're going to set this crossbow bolt into the bow, and we have the trigger set up here. So we've seen the bolt here has hit the target, and it's about 3 to 5 centimeters below the line that we drew using the laser level. Now we can we know that's the vertical displacement due to the acceleration of gravity, and using that we can calculate the amount of time the bolt was in the air, and using that we can calculate the velocity of the bolt.
To calculate the change in time, we are going to use the vertical displacement from the experiment, the local acceleration due to gravity, and the initial velocity, which we know is 0. We then algebraically solve one of the kinematic equations for change in time. We insert our experimental values, and we find out that our change in time is 0.1034 seconds. We are then going to use this and the known horizontal displacement to calculate the velocity. Horizontal displacement to calculate the velocity. The velocity of the bolt after the power stroke is 74.22 meters per second. Now we use the initial velocity of the bolt and the velocity of the bolt flying through the air, along with the change in displacement of the power stroke, to calculate the acceleration during the power stroke. We algebraically solve one of the kinematic equations, and we find out that our acceleration is equal to 6,717.8 meters per second. Now it is time to solve for force using Newton's second law. We simply insert the mass of the bolt and the acceleration, and we find out that our force applied to the bolt is 188.1 newtons.